Hello and welcome to lecture 38. So, in our previous lecture, we solved the cost minimization problem in the short run, and the main takeaway was that if I am fixing the level of capital at a level which is different than my long run cost minimizing capital level, then the cost in the short run is going to be greater than the cost in the long run. Now, we want to do one more example before we start drawing the cost curves. I want to talk about the labor demand curve in the short run, and I want to do this in the context of a very interesting example. So, imagine a firm and suppose we are given data which is discrete and in the following order. So, I have labor which I can use in the steps of increments of 1 unit. So, 1 labor hour, 2 labor hours, 3 labor hours and so on. So, I have 1, 2, 3, 4, 5, 6 and 7. I could also have more amount of data, but this is good enough as an illustration. And suppose I am told that with 1 labor hour and I have some amount of capital which is fixed. So, K bar is fixed at 5 units suppose, right, and let us say the rental rate of capital is rupees 60 per unit of capital, which means my rental rate of capital or the fixed cost is rupees 300, right. So, this is the cost of capital or the fixed cost. So, irrespective of whether I produce 1 unit or 3 units or 4 units or 7 units, the firm is going to incur a cost which is going to be equal to 300 rupees as the fixed cost. So, let us say the output associated with the different combinations of labor input is the following. So, with 1 labor hour, let us say I produce 10 units. With 2 labor hours, the quantity produced is let us say 24. With 3, it is 44. With 4, it is 60. With 5, it is let us say 72 units. With 6, it is 80. And with 7, it is 84. Okay. So, I am given, so this is essentially the data given for output based on different combinations of labor and capital, because recall my production function is Q is equals to f of L comma K. It is just that I have fixed K bar at 5 units. So, I am asking what is the Q where if we have one amount of labor which is and 5 units of capital. In this example, that turns out to be equal to 10. The output when I have 3 labor hours and my K bar is fixed at 5 units is actually 44. This is the way I would want you to read this table. So, based on the production function, we do not have the functional or the mathematical form of the production function, but I have data which is in this arithmetical form. Now, the firm is going to be producing these goods. So, let us say the firm is producing pencils and is going to be selling these pencils at some price, and let us say the price at which it sells these pencils is rupees 20 per unit of output, right. So, I am producing different amounts of pencils with different combinations of labor and 5 units of capital, and I am selling them at 20 rupees per unit. So, if I were to compute what the total revenue is, the total revenue I could measure in rupees. One labor hour is producing 10 units, each of them is being sold at 20 units, 20 rupees per unit. So, that is going to be 200. Then 2 labor hours is producing 24 units, each of the pencils are being sold at 20 rupees per unit. So, the revenue is 480. 3 labor hours is able to produce 44 pencils. So, that gives me 880 rupees. With 4, I have 1200 rupees as revenue. With 5, so that is going to be 1440 rupees. With 6, it is 1600 rupees, and with 7, it is 1680 rupees. So, this is the information about the total revenue in rupees that I have with various combinations of labor. Now, we will compute marginal product of labor in a moment, but I want to introduce a new terminology here. I want to define a term called the marginal revenue product of labor. Right. So, think of this as the marginal product of labor being transformed into a rupee value. the marginal product, recall, is the change in output resulting from a unit change in labor that has output units, pencils per labor hour, but I want to transfer this into a monetary value. So, the marginal revenue product of labor, I am going to call it as MRPL. Let me first define it and then we will see how to compute it. So, the marginal revenue product of labor is the change in total revenue resulting from a unit change in the amount of labor, right. So, I have some amount of labor, I have changed the amount of labor by a unit. The marginal revenue product of labor is the change in total revenue resulting from a unit change in the amount of labor. So, a delta L change in labor is going to lead to a delta TR change in total revenue. So, a unit change in labor will lead to a delta TR upon delta L change in the revenue. So, by definition, my MRPL is delta TR upon delta L, which for small changes is essentially DTR DL, right. So, the derivative of the total revenue function with respect to the amount of labor. Now, notice if I were to look at this expression, the total revenue, so this is DDL, the total revenue essentially is the per unit price times the quantity. So, I am looking at a very specific example where the firm is actually a price taking firm, right. So, a little later in the course we will give a specific name to this firm. We will say that the firm is a competitive firm, which means it takes the price P star as given. So, that price P star is 20 rupees for us, right. So, this is a firm which cannot decide the price P star, it is taking it as given 20 rupees per unit. So, as far as the firm is concerned, this is a constant. So, this will come out of this derivative. So, the P star will come out and I will have dq dl, which means my MRPL is dl of P star q. So, P star times, well, what is dq dl? Well, it is the change in output resulting from a change in labor input, which is nothing but my marginal product of labor. So, for a firm which is a price taker, right. So, let me just make a note only for a price taking firm. Well, what happens if the firm is not a price taking firm? Let us not worry about it, right. I want to keep the computation a little simple. So, the marginal revenue product of labor is the per unit price times the marginal product of labor. Now, I will show you using both the rules. I will start with first principles, compute the value of marginal revenue product. I will also compute the marginal product of labor, then multiply it by the price and show you that they both are equal. So, let us start with first principles. So, let me take marginal revenue product of labor. So, the units in which I am measuring marginal revenue product of labor is change in revenue resulting from a change in labor input, change in revenue is rupees, change in the amount of labor is hours. So, this is measured in rupees per labor hour. These are the units in which I am measuring the marginal revenue product of labor. Now, for the first unit, the marginal revenue product of labor is just 200. So, essentially when I did not hire any labor, perhaps the revenue was 0. So, when we increased or added the first labor unit, the revenue increased from 0 to 200. So, the marginal revenue product or the change in revenue is 200 minus 0, which is equal to rupees 200. So, this is rupees per hour. Okay. Now, what is the marginal revenue product of the second labor hour? Well, I increase my L by 1 unit. I moved from the first labor hour to the second labor hour. My revenue has increased from 200 to 480. So, the second labor unit alone or the second labor hour alone increased the revenue from 200 to 480. So, 480 minus 200, which is 280, is the marginal revenue product of the second labor hour. Now, notice I also want to be a little specific about language. The marginal revenue product of labor is always for a particular labor hour. So, it is for the second labor hour, right. We cannot say that the marginal revenue product of labor marginal revenue product of labor for 2 labor units is incorrect, right. The reason it is incorrect is because marginal revenue product is always for a specific labor unit. Now, if it is 2 labor units, which of the 2 specific labor units are you talking about? Now, here I am specifically interested in the second labor hour. So, the second labor hour has contributed 280 extra rupees to the firm, because when the firm had only 1 labor hour, the revenue was 200. With 2 labor hours, the revenue is 480. So, the revenue has increased by 280. So, the change in revenue is 280. Similarly, we can compute the marginal revenue product for the third, fourth, fifth labor units. So, for the third labor unit, it is 880 minus 480, which is 400. Then for the fourth labor unit, it is 1200 minus 880. So, that is going to be 320. For the fifth labor unit is 1440 minus 1200. So, that is 220 or 240, sorry. And then for the sixth unit, it is 1600 minus 1440. So, that is 160. And for the seventh labor unit, it is 1680 minus 1600, which is 80, right. So, this is the marginal revenue product of labor. So, all I have done is I have said if the firm were to add one more labor unit to its plant, by how much does the revenue change? So, I looked at the new revenue and I subtracted the previous revenue. Okay. Now, a few minutes back I said marginal revenue product of labor is also the price times the marginal product of labor. So, let us verify that. So, if I compute the marginal product of labor, what will I get? So, let us write down the marginal product of labor. So, when I did not hire any labor unit, the output was, let us say, 0. So, when the first labor unit was hired, the output increased from 0 to 10. So, the marginal product of the first labor unit is actually 10 output units. So, 10 pencils. So, the first labor hour produces 10 pencils. When the labor hours increase from 1 to 2, with 1 labor hour, the output is 10 pencils. With 2 labor hours, the output is 24 pencils. So, the second labor unit alone or the second labor hour alone increased the output from 10 to 24. So, that is an increase of 14 units. Similarly, the third labor hour increased the output from 24 to 44. So, the third labor hour alone contributed 44 minus 24, which is 20 units, 20 extra pencils. So, similarly, if I do the arithmetic, so for the fourth labor hour, it is 60 minus 44. So, that is 16. For the fifth labor hour, it is 72 minus 80, which is 12. For the sixth labor hour, it is 80 minus 72, which is 8. And for the seventh labor hour, it is equal to 4, right. So, before I move on, I would urge all of you to pause for a few seconds. Make sure that you understand every term here. Marginal revenue product, what it means, marginal product of labor and what it means. So, MPL is something that we have seen in earlier classes as well. Marginal revenue product of labor is a concept that I have just introduced in today's lecture, and it is attaching a monetary value, a rupee value, to a particular labor unit's contribution to the firm, right. You hired a particular labor unit, that particular labor unit increased the amount of pencils by a certain amount. You sold those pencils at some price, here it is 20 rupees per unit. So, you have computed what is the rupee value of the change in revenue when that particular labor unit was hired. Okay. Now, if you compute simply P times MPL, P times MPL or rather P star times MPL, okay, notice what you are going to get. So, P star times MPL, I know my price is 20. So, 20 times 10 is going to give me 200, 20 times 14 is going to give me 280, 20 times 20 is going to give you 400, 20 times 16 is 320, 20 times 12 is 240, 20 times 8 is 160 and 20 times 4 is 80, right. Notice these two columns are equal, right, which is exactly what we said, right. We said MRPL is equal to price P star times the marginal product of labor. Okay. Now, again I insist this you can do only for a price taking firm. If it was not a price taking firm, I cannot simply multiply the price with the marginal product of labor and claim that this is the marginal revenue product. It will not, right, because here the price does not change at all, the price is constant at 20. So, you could use either of the two rules. If you get the total revenue, I can use the total revenue information and compute the marginal revenue product of labor. Alternatively, I can simply compute the marginal product of labor, multiply it by the price and get the marginal revenue product. Okay. Now, what is the problem that we are trying to solve? We are trying to solve the case where if the wage rate, right. So, suppose the wage rate, so case 1, if the wage rate is rupees 160 per labor hour, right. So, suppose my wage rate was 160 per labor hour. The question is, what is the amount of L the firm will hire, right. We already know that we cannot choose capital because capital is fixed at 5 units. So, if the wage is fixed at 160 rupees per hour, we are interested in finding what is the optimal amount of L. Now, any optimality choice is a comparison between the extra cost and the extra benefit, right. So, the rule is going to be that a profit maximizing firm will choose to hire a certain labor hour if and only if what it contributes to the firm, what this labor hour contributes to the firm is at least as large as what it costs the firm to hire this labor unit, right. So, what we are saying is, take a particular labor unit, take a particular labor hour and ask, should I hire this particular labor hour? Well, I will hire this particular labor hour if what this labor hour contributes to the firm in the form of extra revenue is at least as large as what it costs the firm to hire this particular unit of labor. Now, what a particular labor hour contributes to the firm is actually measured by how much has the revenue increased by hiring this particular unit of labor. That by definition is the marginal revenue product of labor, right. So, that is why we defined it earlier. So, as long as the marginal revenue product of labor is greater than the marginal cost of labor. Now, what is the marginal cost of labor? The marginal cost of labor is essentially the wage rate, because each time you are hiring a particular labor unit, you are paying a particular wage rate. In this case, you are paying a wage rate of 160 rupees per hour, right. So, a profit maximizing firm will choose to hire a certain amount of labor as long as the marginal revenue product is going to be greater than the marginal cost of labor. So, here I am told that the marginal cost of labor is 160, right. So, in case 1, the marginal cost of labor is the wage rate 1, which is equal to rupees 160 per hour, right. And I want to compare where are the marginal revenue product greater than the wage. Well, notice the marginal revenue product here for the first labor unit is 200, that is greater than the wage rate 160. For the second unit, it is 280, which is greater than 160. So, I want to hire the second labor hour. The same is for the third labor hour. So, also for the fourth labor hour. So, also the case for the fifth labor hour. And for the sixth labor hour, it is exactly equal to 160. But notice for the seventh labor hour now, the extra contribution in the form of rupees or the extra revenue that the seventh labor unit brings to the firm is only 80 rupees. But it costs the firm 160 rupees to pay to get this particular labor unit. So, in fact, the firm is going to be losing money on this particular labor unit. So, the firm will not hire the seventh labor hour and the firm will stop at L equal to 6. So, in this case, by applying the rule, L star is going to be equal to 6 labor hours, right. So, for the first example, so L star was equal to 6. I want to find out what the profit of the firm is. Well, what is the profit? Profit is going to be the total revenue minus the cost of labor minus the cost of capital. Essentially, the total revenue minus the total cost. The total cost includes my cost of labor and my cost of capital. Well, what is my total revenue? Total revenue is essentially the price times the quantity, and the quantity produced by these 6 units of labor, because I am hiring 6 labor hours, minus the cost of labor. The cost of labor is the wage rate times the amount of labor that I am hiring, which is 6, and my cost of capital is the rental rate times the amount of capital, which in this example is rupees 300, because R is equal to 60 rupees per hour and I have K bar which is equal to 5. This is given to us. So, let us compute what the output is when the firm hires 6 labor hours. Well, the output is equal to 80. So, 80 times 20, the price is 20. So, that is 20 times 80 minus the wage rate is 160 times 6 minus 300, and this is going to be equal to 1600 minus 960 minus 300. So, 1300 minus 960, well, if you do the arithmetic, you are going to get, so that is 1300 minus 960, that is going to be equal to rupees 340, right. So, the firm earns a profit of 340 rupees in the short run when the input price is of labor is 160 rupees per labor hour and it optimally hires 6 labor units, right. So, I hope this example is clear to everyone. All we have done is we have compared the marginal revenue product with marginal cost of labor. Previously, in our previous examples, we have compared the marginal revenue with marginal cost, right. Recall the CD manufacturing firm. The firm which was producing CDs was deciding what is the optimal quantity of CDs to produce. We compared the marginal revenue with the marginal cost. Now, instead of 160 rupees per labor hour, suppose the wage rate was rupees 320 per labor hour, right. So, the wage rate has changed. So, essentially now I am looking at the example where the marginal cost of labor is W2, which is rupees 320 per hour. In fact, the wage rate has doubled, right. Why? For whatever reason, perhaps the supply of labor curve has decreased. There is a shortage of labor which translates to a higher input price of labor. So, if any firm wants to hire labor, it needs to pay a much higher per hour wage. So, that is 320 rupees per hour. Now, notice how is that going to alter my optimal choice of labor. Now, again I can use the same rule, marginal revenue product equal to marginal cost of labor. Well, if you look at the first few units, right, the first labor hour has a marginal revenue product which is equal to 200, which is going to be lower than 320. Now, that in itself does not mean that I should not hire the first labor hour, because notice, even though I am going to be losing money on the first 2 labor units, from the third labor unit onwards I am going to be making. So, third labor unit I am actually going to be making a lot more. On the fourth, the extra revenue that the fourth labor unit brings is exactly equal to the marginal cost of that unit. So, my net gain is 0, and then I actually lose money. So, I will essentially stop at L equal to 4. Now, in the previous example, I did not have to worry about it. I went all the way, because the wage rate was 160. I checked where my marginal revenue product is equal to 160, and that is where we stopped in the first case. But in the second case, because the wage rate is higher, it is 320 rupees per hour. Even though on the first 2 units I have lost money, my net gains are negative, I am making positive amount of net gains from the third labor hour. And if what I make on the third labor hour is greater than what I have lost on the previous labor units, it might still be profitable for the firm to hire those labor units. Okay. So, applying the formula, so applying the rule, marginal revenue product of labor is greater than equal to the marginal cost of labor, which is equal to the wage, which is equal to 320. The amount of L that I have here is actually 4, is 4. So, my L star or my L is equal to 4, L is equal to 4. So, let us compute what the profit of the firm is. As before, the profit is the total revenue, which is per unit price of 20 times the number of units that 4 units of labor are producing, which is 60 units, So, that is 20 times 60 minus the cost of labor, which is per unit wage rate is 320 times 4, because I have L equal to 4, minus the cost of capital, which is 300. So, this is 1200, this is 1200 minus 1280 minus 300, which is equal to minus rupees 380, right. So, here the profit that the firm is making is actually minus 380 rupees when it hires 4 labor hours. Well, the question is, can the firm do better? And the answer to this is yes, because by not hiring at all, which is to say that L is equal to 0. So, suppose I decided that I do not want to hire at all, right, L is equal to 0, then what is the profit I would have made? Well, the profit would have been the revenue. Well, what is the revenue that I would have earned? Well, if I do not hire at all, well, the output that I produced is 0. Even though I am selling it at 20, my revenue is going to be 0. My cost of labor would be 0 because L is 0. All I will be stuck is with the amount of fixed input, which is the amount of capital. So, my profit would be the revenue, which is 0, minus the cost of labor, which is going to be 0, minus the cost of capital, which is 300, which is minus 300. So, clearly losing 300 is better than losing 380. In other words, a loss of 300 is a better outcome than the loss of 380 rupees. So, the profit is actually larger than the profit in the previous case. So, essentially this means firm is better off by not hiring, and the optimal L star is equal to 0, right. So, we need to be a little bit careful when we use formulas. In the first example, my marginal revenue product of labor equal to the marginal cost of labor formula gave me a correct answer, but when I am using the same formula, that no longer works. So, MRPL greater than equal to the marginal cost of labor equal to W does not work here, right. So, let us try and understand what is it or why is it the case that the marginal revenue product equal to the marginal cost of labor worked in the previous example, but is no longer working in this case. So, let us think of a firm which is hiring L. So, a profit maximizing firm should hire some positive amount of labor, right. See, nobody is forcing me to hire some amount of labor. A profit maximizing firm should hire a positive amount of labor if and only if the profit that it makes by hiring those positive amount of labor is at least as large as the profit that it makes by not hiring, right. Because if the inequality worked the other way, then I am better off not hiring at all. So, a profit maximizing firm should hire some positive quantity of labor if and only if the profit that I make by hiring those positive quantity of labor is at least as large as the profit that I make by not hiring at all. Well, let us look at the left hand side. Well, the left hand side is the total revenue minus the cost of labor, which is W times L, minus the cost of capital, which is R times K, should be at least as large as the profit when L is 0. Well, the revenue is 0, the cost of labor is 0 because I am not hiring, and my fixed cost is my cost of capital. So, essentially I can cancel this from both sides and I will get total revenue minus WL is greater than or equal to 0, which is to say that total revenue is at least as large as my cost of labor, right. And notice that is no longer happening in this particular example. If you look at the total revenue, it was 1200. If you look at the cost of labor, it was 1280. So, the firm was not making enough revenue to even cover the cost of its variable inputs, right. So, the firm is not earning enough revenue to cover the cost of its variable input which is the cost of labor, right. So, if you are not earning enough revenues to cover the cost of labor, and then on top of it if you also add the cost of capital, it is going to be even more negative. So, that is the fundamental reason why the firm should not hire here, and if the firm should not hire, then I need not use the marginal revenue product greater than or equal to the marginal cost rule. So, we can simplify this a bit more and write it as total revenue greater than or equal to W times L. So, total revenue divided by L should be greater than or equal to W. I will just rewrite this as W less than or equal to total revenue divided by L. Well, what is total revenue divided by L? It is the revenue divided by the labor hours. So, that essentially means that W is less than or equal to average revenue product of labor, right, where the average revenue product of labor is the total revenue divided by the labor inputs, which is nothing but total revenue divided by L. This is in rupees, this is in labor hours. So, this is also in rupees per labor hour. Now, before I proceed to the next steps, what I would urge all of you to do is create a column where I have average revenue product of labor. This is the total revenue divided by the labor input. So, essentially I have the total revenue of 200 from one labor hour. So, 200 divided by 1 is 200. 2 labor hours are generating a revenue of 480. So, on an average each labor hour is generating 480 divided by 2, which is equal to 240. With 3 labor hours I get 880 rupees as revenue. So, on an average each of these labor units is generating 880 divided by 3, which is 293.33. Similarly, 4 labor hours is contributing a total revenue of 1200. So, that is generating an average revenue of 300 rupees per labor hour. So, each time I am taking the total revenue and dividing it by the amount of labor units. Similarly, you can check the average revenue product of the 5th labor hour is 1440 divided by 5, which is 288. For the 6th, it is 1600 divided by 6, which is 266.67. And for the 7 labor hours are generating a revenue of 1680. So, this is going to be equal to 240. So, what I would want all of you to do is to again recheck this arithmetic, compute the average revenue product of labor, and there are a couple of other statements that I am going to be making, and we look at one more case. So, the key takeaway here is that if my W is less than or equal to ARPL, it is telling me something that I am not making enough revenue to cover my variable cost of labor. So, there are a few more formal statements that I would want to make. I will do that in our next lecture. Thank you.